Good afternoon, CDT friends. This is the disembodied voice of Tom Bruce. I'm very sorry I can't be with you all this afternoon. I'm on domestic duty with our 12 and 10-year-old daughters. My background's in coastal engineering, so it's natural for me to be looking for synergies between coastal engineering, coastal structures, coastal defence and wave energy. And really there ought to be some synergies there in that one is typically building coastal defence in areas of high wave energy. If you look at the upper right picture there, you can see the breakwater integrated oscillating water column at Mutriku in northern Spain, and the sharp-eyed, eagle-eyed among you will spot that really we're not to be able to see right into the oscillating water column chamber, and so this has actually suffered rather catastrophic failure during its construction. The plant is now commissioned, rated at 300 megawatts, but its commissioning was delayed by around 4 years due to this failure due to wave impact loads during its construction. So this reminds us that there is a shortfall in the guidance on the design of this type of structures, not only for performance but very crucially for survivability. If you look upper left, we have a graphic that reminds us these are very complicated loading systems. There are some slowly varying wave loads on the front, potentially wave impact loads on the front. There's a rather unknown distribution of loads on the inner rear surface, and there may be impact or slam loads within the chamber. So we've got a complicated area, and all of those loads will also be rather complicated to scale simultaneously in physical model studies. Tackling this problem, we undertook in 2014 a series of very large-scale tests at the Grossevellen Canal in Hanover in Germany. And with a bit of luck, if the videos are working and Joe has clicked on the right-hand one, you should be seeing on the lower left video of some waves breaking on the front of the oscillating water column model, and on the right, a rather cute picture taken from within inside the chamber, which really is not this rather genteel rise and fall of the water column within an OWC that we might believe from textbooks, but is a more terrifying prospect involving waves slam on the ceiling, and indeed waves running across the ceiling and slamming on the inside of the front wall. Together with my PhD student Krishna Adipavitan and excellent colleagues from HR Wallingford and from the Second University of Naples in Italy, we're working very hard through this data to work towards developing conceptual models for the loading and some generic design guidance coming out of that. Very interested also in where this leads in the future to other types of coastal defence, particularly interested in whether there is any viability in integrating wave energy with low-cost, low-crested offshore breakwaters widely used for defending erodible coastlines. So if you're interested in this stuff, I'd be absolutely delighted to hear from you. My email is up the upper left there. I'm very pleased to hear from you, or pick up the phone to me. Otherwise, thanks for listening, and again, apologies for not being with you, and I hope the afternoon is good.
This production is brought to you by the University of Edinburgh.